Good afternoon and welcome to today's webinar, which is going to be a live demonstration of LogoPress DieDesign software used with Stampack Forming Simulation software. The webinar is presented by Accurate Die Design Software and hosted by MetalForming magazine. I'm Brad Kubin. I'm the editorial director of MetalForming at the Precision MetalForming Association, and I'm pleased to be the moderator for today's session. Before we get started, just a few notes about today's meeting. It is being recorded for archiving, so the recorded event will be posted to our website within the next few days. When that gets posted, we'll send you an email, and you'll be able to view it online and share it with others. Also, all of the participants in the meeting are in listen-only mode, which means that the speaker and other listeners, other attendees will not be able to hear any audio from your sites during the program. However, you can communicate with us throughout the program by submitting any questions and comments you have. You'll use the question box located in the right-hand control panel on your screen. If you don't see that Q&A button to open that screen up, just click on the More button and the Q&A panel should appear there. So then you'll simply type your question to an organizer as selected from the drop-down menu. And then you'll use that same question panel to ask questions of our presenters at the end of the webinar. So without further ado, it's time to begin today's webinar, which I'm told by Ray is really cool. So we're excited to see what these guys have to present for us today. Our presenters are a trio from Accurate Die Design Software. Ray Praber is going to get us started. He's the president of Accurate Die Design Software. And then he'll be joined by Matt Gould, applications engineer and instructor, as well as sales applications engineer Josh Hellman. So to get the show started, it is my pleasure, as always, to welcome back to our webinar stage Ray Praber, who's going to then bring in Matt and Josh. So Ray, the floor is yours.
Thanks very much, Brad. Hi, everyone. Thank you so much for watching our webinar today. Our focus today is going to be on the relatively new command from LogoPress called Export to Simulation and how well it ties LogoPress and Stampack together. You all may know by now that LogoPress and Stampack are both part of the AutoForm group, so it's fun seeing them tie LogoPress and Stampack together, so to speak. To do this, we'll first do a complete strip layout using LogoPress DieDesign software. That's in the LogoPress strip layout, or the LogoPress strip layout is included in the LogoPress DieDesign software. And then Josh is going to finish by doing a complete simulation on that part that we do the strip for. So without further ado, let's have Matt get started with a LogoPress strip layout.
Thank you, Ray. I'll start out the strip by opening up a solid file. And I'll save it. And we'll create the different stations of the strip. First station is going to be where we'll form this end right here. This will be a station mark. There's a LogoPress feature to mark each station. And I'll name this form end. And we'll be doing this in the reverse order on the stations. So we need to flatten out that end. And I need to isolate it. Split it. And this end I'll just hide while I am flattening this end. And I'll use LogoPress blank to flatten it. Lock this edge. And select the material type. And the mesh size I'll leave it express and compute the 2D blank. And I'll show the rest of the part again. This formed area I don't need anymore, so I will delete it and combine the two bodies together. Oop. There we go. And that's what that station looks like. So insert another station mark. This will be where we are piercing the 4 holes. And I need to remove them for the station before that. I'll just use SolidWorks delete face. Insert another station mark, and this will be for forming that end and coining. And since this is symmetrical, I'm going to add a split line down the middle of it. Helps with the symmetry. Then I need to do, since I already ran a flattening, I need to do a computation reset. So I can do a totally do flattening computation. Back into blank. And I'll just lock these split line edges. And these right here, I'm just unlock in the Y direction. And compute the blank. Then again, this body right here I don't need, so I will delete it. There's our flat blank, and insert our station mark. I'll name it flat blank. And save that. And next I will prepare the part for the strip. And here, so I can show graphical representations on top of there. So I can first select where my die plane face will be, an origin point, and select an edge for my feed direction. I can always rotate the part later once I get into strip if I need to. And I'll save that. And now I can create the strip. I'll give it a name. And I'll enter in a project name. This could be a quote number, tool number, job number, something unique. And this will get added to every file in the assembly automatically. I'll feed right to left. And here I am going to add some idles in between the stations just to get it started. Good starting point. I can always add and remove stations later. Save it. And right now I created a strip assembly and is creating part files and building up the strip assembly. Here's our strip. Start by adjusting some parameters such as space between the parts. Round up the progression. I'll do the same thing down here for strip width. And adjust the position of the part in the X. And I will apply that. Strip updates. Let's see, next I can start creating some punches. Start with internal punches in this station. and I will apply the cuts. This red arrow is the center of force for the punches that are currently in there. They'll start moving around. I'll add another cutting punch. So it creates a part file for a punch, puts me to a sketch and normal to the sketch. And let's see, I'll sketch in a general outline of the punch. And then use LogoPress search the punch outline, converts off of the blank sketch, and I'll add some dimensions. Then I will add some mismatch notches to the punches. There are 3 varieties. I'll start out with a French notch style. Get a little preview. Create that. Mismatch number 2 is down here. And add some fillets. Exit the sketch and extrudes the punch. See our center force moved. I'll add another cutting punch. Sketch in another rectangle for this punch. And then do a search punch outline. Add some dimensions. I'll add some mismatches again to this one. I'll exit sketch. And one more cutting punch for the cutoff punch. Place that right in line with the other punch so I can see the relation between the two. Make sure I'm overlapping. Search the punch outline. Add some fillets. And add some dimensions. Then I can move this punch down to the end. I'll just drag and drop it where I want it. I can also move this punch right here. And I'll apply the moves and the cuts. Next, this station right here, of course, I don't want that to be formed there, so select it, and I'll change that to be a flat station. And this one right here, I will have it remain to be a form and coin. Apply that. I'll add a punch for a pilot. This function, I just have to add a sketch point. And dimension it. Exit the sketch. And then I just have to select the point where I want to place it and enter in a diameter. Here's our pilot punch. I'll apply that. Cut the holes throughout the strip. And then this station right here, I don't need this idle anymore, so I'll delete it. So it's going to delete that station. Everything to the left will just slide over to the right. And then I'll create some form punches. Start out with this station right here. Create the form punch. Select the faces. Name material heat treatment. Go into the sketch. Exit the sketch. It'll extrude the punch and cut off the end using those faces. I'll validate that. And I will create the die half now. Form die and sketch it in. Now you can see it cut the shape on there. Validate that. Move on to the station right here. Create a form punch. Sketch it in. Exit. Cuts the shape on the end of the punch. Validate that. And one more for the form die. Select the form face. Give it a name and sketch it in. There's our die half. I'll validate that. I have all my cutting and form punches in there, so I can now exit out of the strip layout function. It's going to ask me if I want to create an information node. I can check or uncheck, check or uncheck which information I wanted to include. I can also join the part together into a single part for more realistic. I'll say yes to that. It's calculating all the cutting and forming forces with additional information. Hide the strip sketches there. And there you can see the information note. It also has forming and cutting forces for each punch in each station. And it also created a Excel spreadsheet with all that information in it. At this time, I can now export the forming tools, or forming and cutting tools for the simulation. Export the simulation, new LogoPress function. I have to close a couple of files. Save this first. Those two files and start export the simulation. First, I'll go through each of the tooling elements. First is the trim tools. I don't need to include these punches because they will automatically already be included into the blank geometry. The upper form tooling, it already selected them, so I'll just check the element. And you can see here, it didn't catch a couple of faces, so I'll go back and select those faces. And then check the element again. Now we have those faces. Click OK to that. Lower form tools. Check the element. That looks good. I'll select some upper pad tools. I'll select this face and this face. Check the element for that. Make sure I have it selected properly. Yes. And then other geometry. For this, I will select some target surfaces for the springback analysis in Stampack. So this, oops, there's that, select there. Check the element. There's our target. Then I can go to the Export tab. Here I'm gonna check our blank sketch. And I don't want it in the first station, so I'll select these and delete them. And I'll reselect them in this station. Convert right off the blank sketch. And I'll also include the carrier. I'll exit the sketch. There's our blank. And I'll scroll down. We can include or exclude what we want to export, but I'll leave everything checked and hit export to simulation. So right now it's creating all the surfaces and sketches that it needs and exporting them to separate files. And then opens up Windows Explorer window, and it can see here for each of the stations, it exported files. You can see how it's labeled revision 1. And if we did a revision 2 and re-exported, it would have a R2 on them and sort them into a different folder. So I have everything exported from the strip. And so now I'll hand it over to Josh, and he will then import all this into Stampack and run simulation.
Perfect. Thanks, Matt. Go ahead and share my screen with you guys. All right, so we'll pick up right where Matt left off. So we have all of our geometry exported out into a folder structure. So now we can go ahead and get started with the simulation. So this is the interface here for Stampack. And what we'll do to get started with is we'll set the press stroke. And so this is going to be 1 inch. Then we'll head over to our blank tab. And we'll enter in our material thickness. That's just going to be 50 thousandths. We'll leave this as a solid simulation here. And then we'll go into our material manager, and we're going to use that same HSLA. So HSLA, and here's a grade 50. So we'll right click on that and say assign. And now we'll import the blank outline that we had as well. So we'll select that blank that we exported out of SolidWorks and LogoPress. So this is that outline. And then all we need to do at this point is to tell Stampack what the minimum part radius is going to be. And that's going to be 40 thousandths here. And that is used because the minimum part radius along with the thickness will generate what this blank mesh is going to look like. So here you can see that blank mesh. And we also actually want this to be a little bit higher quality. So we're going to up the accuracy to final. And you'll see that the mesh should update here for us as well. There we go. So this is the mesh that we want to run with. The next thing that we'll do is we'll also turn on global strip conditions, just so we can tell the software where this blank is connected to more material. So right here, it's going to be connected to a strip on the left and right hand sides. We can also see that this blank is going to have 3 layers of geometry. As everything gets simulated, we can see things like part failure all the way through each of these 3 layers of elements. So now we'll continue over to our process tab so we can set up our forming operation. And this is just going to be a simple drag and drop of the elements that we exported out from SolidWorks. So here's that first forming operation. I'll get my geometry selected and finish the import. And we can also drag and drop all these components so we can set up whether or not these components are in the press table or the press RAM and what type of component they're going to be. So that one was just added in as a die. I can also take my upper form, add that as a punch to my press RAM. Add my pad as a pad. And for that pad, that's also going to have a press stroke of 1/4 inch. And because we have this coining going on here, we are going to turn on our coining mode. And we also want to make sure that we're running with a little bit higher precision for this. Because we have that coining going on, we just want to get nice, high quality results. So I'm also going to change the running mode here to final tryout. That's just the mode for higher accuracy. Now, just to make sure that everything is set up properly, we can take a look at our kinematics slider here. So this is just giving us a very simple, motion animation of what's going to be happening. So this is going to drop down, pad will make contact first, and then our punch. So it looks like we have everything set up. I will head over to the calculation tab now. And I'll just hit run on this. And while we're running the simulation on this first operation, I'll head back over to our process tab and we'll continue on with the rest of the setup. So this is also going to be a progressive die. It's feeding from right to left. So in this X direction here. So I need to make sure I'm telling the software that we are adding a position operation. And we're going to be moving right to left, so negative 4.2 inches. So we can get to our station with the cutting punches. Now for these cutting punches, there's going to be 4 cutting punches. So I'll add all 4 punches in first. And then now I'll go ahead and select the geometry for each of those. So that's just in my station 70 folder here. So there you see, it just got added. Let me go ahead and get every other one added in here as well. All right, select my 4th. And now I just need to tell the software if I'm keeping the geometry inside these cuts or outside of them. So I'll just go to my point selector and just tell it that we're keeping the geometry outside of these 4 cutting punches. And then also these cutting punches are below our part geometry. So I'm just going to tell it that we're going to be cutting in the positive Z direction. Now that that's done, I'll add another position operation. You'll also see that that'll copy over the pitch number that I had used previously. And then we'll add that second forming operation. So just like before, we'll head over to File Explorer. I could just drag and drop our part geometry in here. So here we have all of that. You can also see I have the target body that's in here as well. I'm just going to hide that for now. We'll be using that in the next operation that we do. I'll finish importing everything. And just like previously, I will take my lower form, add that as a die to my press table. I could take my upper form, add that as a punch. And then lastly, I can take my pad and add that in here as well. This pad is also going to have a 1/4 inch press stroke. And if I want to take a look at the kinematics, let me just move the screen here for you guys. We can see how this is going to move. And yes, that does look correct as well. The last thing that we're going to do is come in here to add an operation, and we are going to add a springback operation. So after our forming is finished, we'll want to take a look at the springback. So I'm going to go into my advanced properties first, and I'm going to turn on use compare to target. That way we can compare springback against something. And now we want to add this target that we'd exported out from LogoPress. And that target surface is just the bottom surface of our blank. So I'll make sure to say bottom here. And then the last thing we'll do is add 3 clamps. And this is just so we can tell the software that we want to keep this center portion here stationary. We're going to keep that flat, and everything else is going to spring back around that. So with that done, I'll come up to the calculation tab. Here you can see our OP10, that first operation finished solving, and we have all of our other operations now. So we can hit run on those. And while that's simulating, I'm going to head over to our results, and let's take a look at the first forming operation that we had. So here's that formed geometry. Can turn on my components. Let's zoom in and take a look at the animation of this here. So the pad holds this material as we have this punch come down, draw some of that material in, and form this web here. It's also forming this coining operation here. If we want to take a closer look at that coin, let me just look top down at this here. And I'm just going to go ahead and add a section view. If we want to take a look at the thickness, looks like it's about 50 thousandths thick for a material, and we're pointing this to roughly half of that thickness. So we can get this nice thickness display. If we go back to looking at the full part and take a look at our safety zones, see if we're having any problems here. Looks like we do have a little bit of part failure that we're getting. If we want to take a closer look at that failure, let's go ahead and jump back to that section view that we had. And yeah, it looks like the failure is just on the outside layer of geometry. So you can see we did simulate 3 layers of geometry, and it's just the outside layer. We can actually take this a step further, look at our TFD map. And this is essentially just showing us values between 0 and 100, 100 being 100%, meaning part failure. And if we just zoom in on these sections here, you can see we're just getting that failure that's happening right on that outside layer of geometry, just that surface deep. So that would be something like orange peel rather than actual failure. So just a little bit of orange peel around this coining operation, but nothing other than that. Looks like everything else finished simulating. So let's take a look at our OP30. Here we'll look at that part animation as well. So here you can see that simple forming. I wouldn't really expect anything to be going on over here as far as any problems. You know, just a simple large radii. So no issues with that, but we're most likely going to have a problem with springback. So let's open our springback. And here we can see in blue, the blue body that we're looking at. This is where the part is at right after the die closes and does that last forming operation. But after the press starts to lift up and open, we can see that our part is going to want to spring back past that. So we're not quite getting to material thickness as far as how much this part is springing back. We can see if we actually compare this to that bottom surface of the CAD model, you can see how far we're kind of deforming here. And we can also look at this distance to target result type. And looks like we're about 40 thousandths. Let me make this a little bit easier for you guys to see here. We'll just set these tolerances to plus minus 40 thousandths. And you can see that a lot of this part is perfectly fine, but this back edge is having a lot of problems with this spring back. So in order for us to correct for that, we're going to head back over to our process tab. And we're going to do something called springback compensation. So we can tell the software, this is the geometry we want it to change. And the software will actually change up the forming geometry in order to counteract that springback. So the station we're going to want to run that on is our last station, that OP30. So what I'm going to do is just make a duplicate of that part geometry. So this is the form geometry that we're going to be using this with. And for a spring back operation here, I'm going to go to the advanced settings for spring back compensation. And just like previously, it's just a simple drag and drop to bring our geometry in here. So I'll set up my my lower form as a piece of geometry that can be compensated. Same thing with my upper form. And then also I'll set up my pad here, but my pad I'm going to set up as a constrained surface. This will allow me to add extra constraints to it. For my pad here, I want this to remain perfectly flat. So I'm just actually going to say it's going to be fixed in the X, Y, and Z. But the benefit of this is that the geometry on the other side of the blank, so this portion here of my my bottom form tool in pink, that'll stay perfectly flat because I have this pad here fixed. So only this this geometry over on the right-hand side should be getting modified by Stampack. So with that done, I'll head back over to the Calculation tab, select our spring back operation, and we'll just go ahead and rerun that real quick. Should only take about 10 seconds here. And I'll head over to the Results tab as we wait. I can also open up our process information to see where the simulation is at. This gives us a nice little feedback as the simulation is running, and it just finished. So I'll go ahead and open that spring back up. And let's take a look at what's happening. So here I'm going to show the bottom and top forming surfaces that we have. And as this component here, as this blank starts to spring back and it springs upwards, our form geometry will be compensated downwards. So it'll just be compensated in the opposite direction in order to correct for this. So this is something that Stampack is taking that geometry and modifying it for us. So what I can now do is either export this geometry back out and bring it into CAD, or what I'll be doing now is just verifying that this actually works. Maybe we would have to do a second iteration of this. So we're just going to make a copy of it first and just verify that everything is now correct. And I'm also just going to rename the new components that we got here that Stampack created. And we'll be replacing the geometry of our second form station with the new geometry that we have here. So you can see the new geometry, it's in both of these green colors. You can see now it's just overbending it a little bit more. And again, just a simple drag and drop. Oh, hold on, I just put the lower and the upper. Let me go ahead and make another copy of that real quick. All right, I'll put the upper and the upper, and the lower and the lower. There we go. Now that looks better. And then I can go back over to my spring back operation and to my advanced settings. And I'm going to turn off spring back compensation since we should no longer need that. Now I can select the forming operation, that last forming operation that we had in our spring back, and rerun that. So this is nice just while we're waiting here. You don't have to re-simulate everything from scratch. You can pick exactly when you want the simulation to pick back up if you did make any changes to any kind of form tooling. So it's a little nice, time saver that we have. And also, if this geometry does turn out to be good, just like what I said before, when we're on the Results tab, we can select that geometry, export it back out, and actually one of the new features that I believe the next version of LogoPress, or maybe the version after, will have in it is going to be a nice import function where the geometry that we directly export out of Stampack with just a few button clicks can be brought back in into LogoPress, and it'll take that actual punch geometry that you have and it'll update it with these new surfaces. So it's really nice that they're able to, speed up that process a lot more and, just make things pretty simple for the user within just a few button clicks. So let's head back over to our results tab now. I'll open up our process information and we can see where we're at with the simulation. We can see the elapsed time here in this middle column, and we can also see the amount of press stroke remaining in the simulation. So it looks like it's almost done. Yeah, about 10 thousandths left. We'll go ahead and click on our OP30. And this is real nice too. While the simulation is still running, we can actually load partial results. So here you can see we just had a little bit of simulation left to run, but we can actually load it in exactly with whatever geometry has been simulated so far. So we can load in these partial results and fully take a look at them with things like safety zones and all the section views that we were doing earlier. Let's go ahead and load in those spring back results now that that just finished. We'll look at our distance to target. And I can set my maximum tolerance here to 40 thousandths, minimum to negative 40 thousandths. Yeah, and this is looking a lot better. So before we were just shy of 40 thousandths that the part was springing back. Now we are forming this and correcting all of that. Actually, it looks like we're about 2 thousandths-ish. Here I can do a quick command to see how much. Okay, it looks like we're about 3.5 thousandths over bending the part now a little bit. So we can always go back through this whole process and try to dial this back a little bit further and try to get things real dead on. But this should be just fine for what we have to do here. So at this point, everything seems to be fixed except if I look straight on this part, we can see that the full simulated part does have a little bit too much geometry here on the sides. The simulation did suck some of this down in to form this web, but not as much was actually used as what we had. So this is something that we can also optimize inside of Stampack. To do so, I can go back to the Process tab. And I can simply turn on Trim Optimization. I can use this to optimize that blank shape, optimize those cutting punches. So the first dropdown that I have here, I can just tell the software which operation are we really going to be taking a closer look at. Which operation are we going to be forming with? So let me just go ahead and show just that operation over here. You can also see just a red outline of where that blank geometry is, the profile that it's going to be optimizing. And now at this time, we can import our target line. And this is just some simple target geometry taken again from CAD. And this is just taken on the outside or the top edge of the CAD geometry that we had. So I'll make sure to change this blank surface here to top, since that is what we're optimizing against. We have that top edge. And then that's everything to set up our trim line optimization. As you can see here at the bottom, this simulation will run until it either hits 5 full iterations of the software optimizing the geometry, or until it reaches a maximum tolerance of 5 thousandths. For something like this, I might want to change that to 1 thousandth and see, just how close we can get this. Now at this point, we could go back over to the calculation tab and run this, but this first operation here takes a few minutes to run. So I do have that pre-solved. All that's being done is we're just running that same simulation 6 times in a row. In the case of this here, it took 11 minutes to run. So that's what I have here. And I could head over to our results tab. Let me just back this up for us here. All right, so this is what we can see in blue. This is the simulated geometry. This is just that outside profile of the simulated geometry. And in green is that target profile that we brought in. And you can really see just how far off we are after everything is formed right now. So too much material on the left and right hand sides, too much material on the bottom here. And what I can do is I can click through this here, through the new iterations that Stampack made. And you can see that it took that geometry from being real far off. Actually, it was an average of 20 thousandths off. Now it's an average of 8.5 thousandths off. Oh, an average of a little over 2 thousandths. And yeah, here we're at 5/10 thousandths averaging. And max tolerance of 2 thousandths. I can also look at a nice graph of this as well. Make that a little bigger for you guys. And we can see that over time, as the software keeps iterating upon itself, taking that blank shape, that original blank shape, and making those modifications to it, we're able to take that deviation, that tolerance, and really, really reduce this to, not much left. We can also take a closer look at the results themselves. We can go back over to our forming tab, where we can take a look at the 3D of this. And here we can see that that simulated part really matches up perfectly with what we had from our CAD. So we can head back over to the boundaries tab. And in red, you can actually see the new blank geometry. So the new blank is just going to be slightly larger than that starting geometry. Compared to what we had generated and thought of before inside of CAD, it was coming out way too far. So now we're able to bring that in a little bit closer and have a little bit more accuracy here. So I can take this new blank shape, just click the export button, and I could save this off as an IGES file and go ahead and import that back into CAD now. And that is everything that I have on my end. So that should take it from that Parasolid file, create the strip, simulate the strip, find a few of these issues so we can go back, perfect that strip layout, and then continue on with the rest of the DieDesign. All right, Brad, I'll pass it back to you to finish things up with.
Fabulous. Wow, that really was a great demo. So thanks, Josh and Matt, for that. We do have a little bit of time for questions. If anybody's got some questions for these guys, go ahead and fire them away in that Q&A panel. I'm curious if one of you guys can answer in terms of the types of parts that you can do with Stampack, maybe size limitations. Can you speak to that? Flat parts drawn, and maybe size limitations with Stampack.
Josh, I guess I'll hand that off to you. I think there's no size limitation with Stampack, but it's especially good with anything that needs to be coined or drawn, stuff that you can't do with shell simulation.
Yeah, exactly. So the thickest, the thickest automotive pieces that are, 1/4 inch thick, thicker than that even, down to tiny electrical components. We can simulate all of that. There really isn't any limitation for the size or the types of parts.
And
Okay.
the shell simulation is typically used for much bigger parts. Solid simulation does take longer to run, but the shell simulation is what you always want to use initially to sneak up on the simulation, so to speak, for speed. And then to really fine tune it once you get there, you use the solid simulation, and that's when you really get incredible accuracy.
Gotcha. Okay. How much experience does would you like to see a user have with SolidWorks before it made sense for them to invest in LogoPress?
Really just getting comfortable with SolidWorks sketches. From an experience standpoint, we really just ask that they be trained in SolidWorks first before they take the LogoPress training, and
Okay.
focus on understanding 3D sketches in SolidWorks. as well as know something about assemblies. But we've had lots of people that have, after a week after the SolidWorks Essentials training, a week or two later, as long as they've got some time to practice with it, come to LogoPress training and do just great. But you can pick up
Excellent.
things a lot faster than by getting LogoPress training earlier rather than later, because we make a lot of things in SolidWorks much faster than with SolidWorks alone.
Sure, that makes sense. Okay. Can Stampack show the results of the forces acting on the clamps during that springback operation?
Not on the clamps. So those were just used for us to locate the component. But as far as like residual forces, you can go in and there is a few different results types that I didn't really show. But you can go through some of those result types to see what kind of reaction forces there are in there. I know I didn't show it either, but for instance, the pad that we had used was set to automatic force because we don't know what kind of forces we needed for that pad. And what we can do at the end of that simulation, right in that results section, there's also a graph that you can open up for every single component that you have in there. And you can see the forces over the full press stroke. So if you wanted to know how much forces were used for a pad or how much forces, for instance, would be used to hold a component down and prevent that spring back, you can actually go through and look at those forces.
Okay. The question is about correlations. How close is the correlation between software to reality? Do you have any history you can share on that?
We've got I've got one customer in particular that when I asked him recently, we did an ad on it, that the trim line optimization in particular is absolutely spot on, and springback optimization is pretty significant. We don't have enough. It's one of those things you don't until you see it out in the field and hear lots and lots and lots of people talking about it. But again, we know the trim line is absolutely spot on, and springback is quite good. But it's the press tonnage is really incredibly accurate as well.
Yeah, that's the next question. So you jumped me there.
Sorry about that.
Tonnage calculation, so pretty accurate then, huh?
Yeah, very much so. And with coining, that's a really, really big deal. And we can actually coin a terminal, for example, a terminal blade, and while it's getting coined and squished out, do the trim line optimization at the same time.
Okay, excellent. Can you build the whole prog die in SolidWorks using LogoPress? And if so, they'd like to see a demo, which maybe that's asking a little bit too much on this, put you on the spot here, but can you speak to that?
It's not at all. Yeah, you can go to our website and go to videos under LogoPress videos and look for real-time die designs. And I think, well, I'm not. We're the only company in the world that has a real-time complete die design from start to finish, including the drawings as well as multiple design changes.
Okay. And what's the website, Ray?
DieDesignSoftware.com and /videos.
Okay. Good. And you want to share an email address just in case people want to email you after this?
Sure. It's ray.praber, P-R-O-E, B as in boy, E-R, at DieDesignSoftware.com.
Okay, cool. We do have one more question. We'll take it. We're right at the top of the hour here. Can Stampack be integrated with Creo?
No. Well, I mean, it can't be. When we talk about integrated, the export to simulation command can be used for any simulation software, so or for any CAD software. So yeah, we can take the export simulation when you're in LogoPress, but we don't have that particular command. But as far as using Stampack with Creo, it can be used with any CAD system or any CAD system, because the CAD system you're exporting step files or Parasolid or IGES files, and so any of those can be brought into Stampack.
Gotcha. All right, so I'm going to ask this one. I'm not sure I know what it means, but hopefully you do. Does the springback comp can it be applied to the S SW model.
SolidWorks model, I suppose.
SolidWorks. Okay.
Yeah. Josh, you want to
Yeah,
explain that?
that was right what I was saying at the end there, is that of that section, is that what we can do right now is export that geometry out. I actually just had a beta version of LogoPress on my computer, and I was just playing around with the new function that they're adding in, where you can take that export that you're getting from Stampack, and with just, I think it's just 3 button clicks or 2 button clicks, you can take that surface and apply it back in and into SolidWorks, into LogoPress, and whatever punch that you had that you exported that out from, that punch will just be updated with that new geometry. So from kind of testing around and looking at it, it looks like it's about 30 seconds to go from exporting from Stampack to my design is now using that new component. So that's a new feature that's coming into one of the next versions of LogoPress here. Other than that, right now, you could always just export it out, bring it into SolidWorks and work with it traditionally. But there is, some new functions coming out to make the transition back and forth even easier than it already is.
Okay. Very good. Well, that brings us to the end of our demo today. Thank you, Josh, Matt, and Ray for an outstanding demonstration of the software. To our audience today, thank you for attending the program. We hope you found it to be a valuable experience. Again, an archive of this event will soon be available on our website. So when that's ready, you'll receive an email from us, and then you'll be able to review it and what you learned today, and perhaps share it with others within your companies. So again, thank you to Accurate Die Design Software for sponsoring today's demo, and to you for attending the event today. You may close your browsers now and have a great afternoon.
Yeah, thanks everyone. Bye-bye.